Hey there, everybody. Uh, this is a video for the review. So hopefully you've actually done it. Worksheet 6 or the review for the atomic structure unit. Now, as you can see, I mean, this is what we did in class in terms of, we kind of went through and answered all of them. I wrote it all in. And I'm going to just leave it like that. And then hopefully we'll have this conversation, and I'll keep bouncing back and forth between this and the table so you can see kind of where I'm looking and where you should be looking for this information. All right, so follow along. For the valence numbers, now again, I told you no on the oxidation numbers, you don't have to know that. But for the valence numbers, cesium, well, first of all, trying to find cesium might be an issue. Because it's not one of the ones that you were supposed to have known. But cesium is down here, number 55. And if you look way, oh boy, can I actually zoom in further? Oh boy. Oh boy. Oh, look at that, cesium right there. Do you see there's a 1 down there? So 2, 8, 18, 18, 8, and a 1. Right there. So the 1 is the valence number. It's also in group number 1. So two places you can find that cesium has a valence number of 1. It's in the alkali metals. Oh, that's another question that's going to come later. So it's in the alkali metals, and they're all 1s. 1, 1, 1, 1. So again, ooh, there we go. So they're all 1s in that column. So if we go back, that's a 1. Tin is a 4. Now, how do we know tin is a 4? We find tin over here. Number 50 is tin. And notice at the bottom, it is a 4 down here. The last electron number is a 4, which tells us that is the valence number. And it is, well, in this case, it's a Roman numeral 4. That is the valence number. Now, it's not the group number. It's group number 14. Okay? If you count from left to right, 1, 2, 3, 4, all the way across there, that is actually group 14. So on the table that's hanging on the wall in the room over here, that will say 14 above the carbon group here, and that is a 4 for a valence number. Okay, and lastly, chlorine. So chlorine, whoa, okay. So chlorine, we're over here, number 17, and you see then at the bottom of the chlorine box, it is a 7 at the bottom of the chlorine box. So there you have that, which again, at the top of this column, on your table, is a Roman numeral 7, which is the valence number of the whole family. And on the table that's hanging in the room, it says 17 at the top. So it says 17 up here, and the 7 of the 17 is the valence number. All right, so if you weren't sure before where to find valence number, hopefully you're sure now where to find it, because, again, I just showed you. Now, back to this. You're supposed to state whether these elements are metals, nonmetals, or metalloids, which leads us back to the table. You're supposed to know that this stair-step line here is the border between the metals on the left over here. Notice it says metals right here. Those are the metals, with the exception of hydrogen. And then the nonmetals are on the right side, and the metalloids are on the stair step. So we have boron, we have these two, arsenic and antimony, and then we have tellurium and polonium, these two. Some people say astatine is as well, but these two for sure, these two for sure, these two for sure, and then boron, just the top step here, not aluminum below. So those were the 7 I told you were supposed to know. So if we look at what the sheet says, 1 is potassium, or no, sodium, sodium, which is over here, which is on the left side of the table, which is a metal. We have iron, which is right here, again, on the left side of the table, left side of the line, which is also a metal. Then we have boron. Boron is here. Ooh, it's on the top step. That's a metalloid, right? That's a metalloid. And then we have aluminum, ooh, which is right below boron. That's a metal. Okay, aluminum, left side of the line. It's not one of the metalloids. It is a metal. And then next we have carbon. Carbon is a nonmetal. Oh my gosh. So these three right here, see, they're all right at the border. So metalloid for boron. Below that, aluminum is a metal. And then to the right of boron, see, carbon's not even on the step. And so it is a nonmetal on the right side of the dividing line. So aluminum is kind of the exception. Remember, it's top and bottom on the second step, top and bottom on the third, top and bottom on the fourth. Okay, so aluminum is the one that isn't a metalloid that's on the top and bottom of the steps. Okay, where was I? And bromine. Bromine's over here, and it's a halogen, and it is clearly on the right side of that dividing line, and so that is a non-metal. Okay, state the family. So the next section is the families of these elements. And again, remember, there's four main family names. You have the alkali metals, the alkaline earth, then the halogens, and of course your table actually tells you the noble gases. So if we look at the first one, potassium. Potassium is over here. It is in the very first group, group 1, which is the alkali metals. Let's see, antimony. Antimony, which is over here, SB, antimony, is in the, well, this doesn't have a regular family name like we had talked about. So we just say it's the nitrogen group. It's the group of the top element in the group. Nothing to memorize here. It's literally, you look at the table, you see where it is, antimony, and you say, oh, it's in the nitrogen column, in the nitrogen group. That's why we call it the nitrogen group. Hopefully you're getting that. Fluorine, which is up here. It's in group 17, which is the halogens. So group 17, the halogens. And calcium. Calcium's way over here, number 20 on the left side. So calcium is in the alkaline earth metals. Alkaline earth metals. And let's see, xenon over here on the far right, that is in the, look at that, noble gases. They told us what the name of that family is. And then we have oxygen here, the last one, which is clearly in the oxygen group. It is the top element in its own column. And so oxygen is in the oxygen group. Now you can call it oxygen group, or you can call it oxygen family. You can call this one nitrogen group or nitrogen family, carbon group or carbon family, boron group or boron family. I don't care which way you say it. I would accept either one. But you have to have group or family, because that's, you're telling people what you're talking about. If you just say boron, like aluminum's in the boron, well, what does that mean? The boron what? The boron group or the boron family? You have to have that in there, or we don't know what you're talking about, right? If it's just the element name, then it's just the element, not the family. Okay, back to here. Okay, then we had, where's the element located? The spot on the table. So I gave you group numbers and period numbers. So you then, using those group and period numbers, you have to look at the table and figure out, okay, where are these things? So the first one was group 2, period 5. Group 2, so group 1, group 2, 2, and then go down to period 5, and so that's strontium. Strontium is the element at group 2, period 5. Then we look over at group 16, period 1. Group 16, period 1. So we look over to group 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16, group 16, period 1. Period 1. 16 is all the way over here at oxygen, and period 1, which is the top row. And we look over there, and there's nothing there. There's nothing there. Nothing at group 16, period 1. Nothing there. So you just write nothing. Nothing there. Or empty. Or no element. There's nothing there. It's kind of a trick question. And let's see, we look down to C. We have group 6, period 6. Group 6, 1, 2, 3, 4, 5, 6. So this is group 6, Period 6 is down here. So that's tungsten, number 74. That's group 6, period 6, right there. Got that? And let's see, where was I? Oh, yeah. We are at D. Group 10, period 4. Group 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So group 10, period 4. Oh, that's right here. Period 4, group 10. That's nickel. Nickel is group 10, period 4. And fluorine. Fluorine's over here. I just told you the answer. Oh my gosh, group 17, period 2. Group 17, oh my gosh. Well, this is 18 all the way on the far end. So 17 is one short of that. So the group 17, period 2, which would be the second row, the first, now again, it's not, the period number is this number over here, okay? You don't start with, like, period 4 is not actually period 1 for these groups. That's the first one that there's something there, which means it's empty. Period 1, period 2, period 3, it's just empty for these groups 3 through 12. Okay, so make sure you're looking over here at the period number, or you'll get yourself messed up. Don't count down. So if you go over here to period, or to group 17, and you say, okay, 1, 2, well, you're going to think it's chlorine, but in reality, it's 1, 2, because the first one, there isn't anything, and then the second period is where fluorine is. So fluorine is the answer for group 17, period 2. And finally, group 11, period 6. Group 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Group 11, period 6. So that's 4, 5, 6. So, oh, it's gold. How about that? That's gold. So group number, period number, you have to be able to find where these elements are. All right, moving on. Now, in terms of drawing these, okay, now we've done these before, and you've done these before. Normally, the ones we've done in the past, there are multiple correct answers for these. But in this case, there are not multiple correct answers. There's only one. One correct answer. Because I said it has a mass of 27 with 3 more protons than sodium. I'm locking you in. There's only one element it could be. It has to have 3 more protons than sodium. So if we look at the table, 3 more than sodium. Well, sodium's right here. Okay, so 1 more, 2 more, 3 more protons. So 11 to 14, 3 more protons than sodium is silicon. It has to be. It has to be the answer, silicon. Now, we know that silicon is number 14, so that tells us, since the atomic number is 14, that means we have 14 protons. Since the mass is supposed to be 27, we know that 14 and whatever the neutron number has to add up to 27. You're supposed to know that. You're supposed to know that the mass number is the proton plus the neutron. So 27 minus your 14 protons is your 13 neutrons. Okay, these two have to sum to 27. So that tells us that there's 13 neutrons. Now, it also has to have a charge of plus 3. If we have 14 protons, which we already established, and those are all positive, the only way to have a total charge of plus 3 is if we have 3 less negatives than we have positives. Okay? The electron number has to be 11 because we have to have 3 fewer electrons, 3 fewer minuses than we have pluses. That's how you get a plus 3. So that has to be the case. And again, it has to be silicon. So this table gets filled in, then you can just sketch your stuff up. Now notice how I've sketched it. It's clear. I have a key. It is clear. I can count these particles easily and tell how many of each I have. They are distinctly different. My neutrons and my protons are distinctly different. And then my electrons are just the dots out in the outermost levels. Now notice I have one here, one here. The first level only holds 2. Then I have 2, 4, 6, 8. I have 8 in the second level. That gets me to 10. And my 11th one then has to go out in the third level. That's going to be critical. You have to remember that the first level only holds 2. Second level holds 8. Anything beyond 8 has to be in the third level. And if you have beyond 8 and 8 and 2, if you have beyond 18, then you've got to go out to the fourth level. Okay? Everybody got that? Hope you have that. Now you're supposed to create the symbol. Now how do you know where to put the stuff for the symbol? Okay. It's just like your own table. The symbol, I would say the element symbol or name has to go in the middle. You could write the name out, silicon, or you could just write the symbol SI. That's fine either way. Top, middle, I would put, just like your table has top, middle, is the atomic number, which is, again, the proton number. I'd put that right there. This told us the mass was 27, so I would put 27 in the bottom. Do not look at your table and put, let's see, what is silicon? 28.0855. Do not put the actual average atomic mass in here. That's not what this atom has. This atom has a mass of 27. So put 27 in for its mass in this symbol, okay? And the last thing, which isn't actually on your table, but it is for this little symbol tool thing we were using on the simulator, the +3, the charge, I would put in the upper right corner. That's where it was going online for the Atom Builder simulator. So that's how I would do that. That's the first page. And the second page of the review, we have another one of these examples. So this one, again, I'm in the way. I locked you in. It has to be the element that has 4 less protons than neon. 4 less protons than neon. Well, neon has 10. What's 10 minus 4? 6. 6 is the number of protons it has to have, which means it has to be carbon. Has to be carbon because carbon has 6 protons. It is number 6. Mass of 9 means 6 plus your 3 has to total 9. That's how we know that neutrons is 3. So again, 9 minus 6, 3 neutrons. And it has to have a charge of -5. Holy cow. A -5 charge means we need 5 more electrons than protons. 5 more minuses than pluses. That's how we know that has to be 11. Has to be 5 more than 6, which gives us 11. So there's 11 more minuses. There's 11 minuses, which means there's 5 more of them than the pluses. And of course it's carbon. So then you sketch it out. So I've got 1, 2, 3, 4, 5, 6 protons in there based on my symbol. I have only 3 neutrons in there. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and my 11th electron. Oh, it's the same electrons as the last one. In terms of the symbol, again, you put your proton number in the top middle, you put your symbol in the middle, you put your mass in the bottom, and then your charge in the upper right corner. That's just how we do them. And lastly, this one, I gave you the symbol. You had to kind of get this figured out and then draw it in, okay? Because it's magnesium and has 12 protons, that's what this tells us, then you know you have 12 protons. Because it has a mass of 25, again, you do not look at the table and look at magnesium and say 24.3050. That's not the mass of this magnesium atom. I'm telling you it's got a mass of 25. So you use 25 then to tell you that you have 13 neutrons, because your 13 neutrons plus your 12 protons is what gives you your 25 for a mass. Now, there's nothing up here in the upper right corner, which is where we've been putting the charge. If you see nothing in the upper right corner, then I assume it doesn't have a charge. If it doesn't have a charge, then what do you know about your protons and your electrons? They have to be the same number. Equal numbers of pluses and minuses makes no charge. So then you just sketch it up. I have my 12 protons in here. I have my 13 neutrons, if you count them up. And then I have 2 in the first level, 8 in the second level, and another 2 in the third level for a total of 12 electrons. Now, for number 10, how do you know how to draw the atom above? So how do you know the proton number and the mass number and the charge and the neutrons and electrons, all that stuff? Well, again, that's what we've been saying. You know the proton number because it is the atomic number. That's what it's called. The atomic number is the proton number. How do you know the mass number? Well, it told you that that is the mass number. And you use the mass number with the proton number to find the neutron number. Again, protons plus neutrons has to equal that. How do you know what the charge is? Well, it tells you, and in this case, it didn't even have one, so we didn't have a charge. So we knew it had to be neutral, which tells us that our electron number and our proton number has to be balanced. That's how we know. And lastly, what is an isotope? An isotope is when more than one atom, multiple atoms from the same element, have different masses, which means they have different numbers of neutrons. So that's what an isotope is. You need to know that that's what an isotope is, which goes back to, let's see, I got to get on the previous page, which goes back to this part. If I were to ask you in this, we skipped this part. Oh my gosh, I didn't even do this part. My apologies. I'm glad that I just thought of it. So for part 6, you were probably wondering why I skipped it. Part 6, you're supposed to determine how many neutrons each of these has. You have to remember that this number right here, that 37, is the what? That is the mass number, okay? That is the mass. I'm telling you the mass. So if I were to ask you, hey, what's the mass of chlorine-37? You would tell me what? It's 37. That is the mass. I'm telling you the mass. Well, then how do you find out the neutron number? Well, if you know that we're talking about chlorine and that chlorine is number 17 on the table, that means it has 17 protons. If its mass is 37 mass minus 17 protons means you have to have 20 neutrons. Because remember, these two have to add up to that. Your proton and neutron number have to add up to your total. So it has to be 20 neutrons. Plus your 17 protons gives you your mass of 37. Okay? Silver 109. You don't have to look at the table to find the mass because I gave you the mass. You do have to look at the table to find out, okay, where's silver? Okay, right there, number 47. So it has 47 protons. Oh, I need that information. 47 protons. All right, take that away from 109 and you get your 62. Okay, 62 plus your 47, that's where your 109 comes from. Okay, hopefully you're seeing this. So carbon is number 6 on the table, which means it has 6 protons. 13 minus 6 is your 7 neutrons. Sulfur 67. Sulfur's number 16 on the table. That means 16 protons. If you take 67 mass minus your 16 protons, you get 51 neutrons. 51 plus 16 has to equal the mass. And phosphorus 40, phosphorus is number 15 on the table, so that's your mass, or that's your proton number. Take that away from your mass, and you're left with 25. You got to have 25 neutrons plus your 15 protons to give you your total mass of 40. And lastly, we have titanium, which if you look on the table, is number 22. So 22 protons. To get a mass of 49, 49 minus your 22 is your 27 neutrons. You got to have 27 neutrons plus 22 protons to have a total mass of 49. So hopefully you got that. Okay, last thing. If you have not looked back at it, you need to look back at the elements lab that we did. There's a paragraph at the beginning that talks about characteristics of metals, nonmetals, and metalloids. Okay, things like metals are shiny, they have a high luster, they're good conductors of heat and electricity, they are malleable, most of them. Some of them are ductile, which means they can be drawn into wires. So those are some properties of metals. Some of them are even magnetic. Then for nonmetals, they're exactly the opposite. They are poor conductors of heat and electricity. They are brittle, not malleable. They are dull, not shiny. So those would be non-metallic properties. Now, what about metalloids? Well, in that little paragraph, it talks about how metalloids can be kind of like metals in some ways, but then kind of like non-metals in other ways. They can be kind of shiny like a metal, and they can conduct a little bit like a metal, but they can also be very brittle. So you hit them with a hammer, they might shatter, whereas a metal wouldn't do that. So you need to look back at the lab, look at all your fill in the blank parts, and make sure you know the characteristics of metals, nonmetals, and metalloids. I think that's about it. So good luck. Hopefully you know how to do all these things now if you didn't before. If you're still not sure, go back and rewatch parts and maybe it'll click. Okay, I think I'm finally done. If you have not been here for an extended period and you won't be back until after break, well, then we'll take care of all of this after break. So don't just do nothing for a month and then try to cram all this before you take this after break. I mean, I would, yeah, you may have to watch this video again and maybe that'll help. So anyway, stay safe and hopefully we'll see you soon.